Okay, great. So welcome to From Zero to 60 Foundations in Machine Learning. This is part of the AI in the Wild series. This is really the first course that really focuses on machine learning. So it's trying to give you the foundations in machine learning or ML so that you can start your journey about learning more about the topic, building the foundations so you can go towards more advanced topics and different areas that will be suitable for your learning journey. Okay, so what I want to cover in this introductory explainer is just a bit about who I am. So why am I talking about machine learning? Why are we talking about machine learning? But particularly why AI in the wild? What do we mean by AI in the wild? We'll then go through what we're going to be looking at in this particular course, that's the word, and how it fits in with the series. So what came before it, what's going to come after it, so you can understand if it's the right time for you to do this one or should you do a previous one, etc. And then we'll talk a bit about how. What is this course? It's an online learning course, but how do you interact with it? How will you learn through it? What are the touch points of help you can get as you become fluent in machine learning? Okay, so yeah, awful picture of me, but you can see me in the bottom right hand corner, right? So a bit about me. I am the CTO and co-founder of Digilab. I'm also an academic. I'm a professor of machine learning at the University of Exeter. My career has been really focused on an area called data-centric engineering. And so what do we mean by that? It's about, well, predominantly engineering systems, physical systems, but all sorts of applications. And what I'm interested in is about there's lots of data in these systems. There's also lots of sophisticated computer models. And my background has been about how you bring those together to help you make good decisions about engineering, be it, is this bridge safe, or how do we build a fusion reactor? All sorts of fundamental questions which need machine learning to really advance them. So I'm passionate about AI in the wild. I feel that a lot of education in machine learning really focuses either on the weeds of the mathematics or not on real world data. When you go out in the wild and you work with companies or in your own company, you'll find that data is not clean, is not perfect, hasn't been aligned. The questions aren't always clear of what or how you should do it. Understanding that data is like that and understanding the tools and techniques you can use to understand data better is really important. Also, I think because of the really good libraries that we have in machine learning, where people have thought carefully how do they construct these tools so you can get the most out of them, then you don't need to necessarily know all the details about the maths. The important thing is to understand the high-level concepts and understanding which methods, which tools are appropriate for the different tasks. I think, something that will drive this clearly about how you might want to use this course. It's fundamental to me that as we accept machine learning, how we're going to use machine learning, we need to lower the barrier to entry. Some people don't program. It's just not something that they've done in the past. To be knowledgeable about machine learning, to understand why or how you should use machine learning, to understand what machine learning is and what it's not, you don't need to be a programmer. Hopefully in this course we will show a path or journey for you so you can understand those high level concepts and dip into the more technical sides. But if you don't want to do that, you'll still extract good information that you can use in your jobs. A typical example of this would be just to become more savvy. If you're leading a team of people that might use machine learning, understanding the principles behind it so you can make good decisions about your team is a natural sort of skill set that I want to encourage. Okay, so why AI in the wild? I've kind of already gone through this. I've already jumped the slide, but just to just focus on what we really need, I think, in industry now is what we call AI practitioners. It's not textbook AI. It's about understanding how you go and do it in the wild. And it's really about cutting through the hype. Machine learning is often seen as magic. It's not magic. It's a set of well-defined algorithms that sometimes well-defined, but it's a set of algorithms often in combinations that you can use together, which are define a process from probably data to decision. Understanding this, understanding that it's not just voodoo magic, is really important to understanding how you deploy and trust algorithms or don't trust algorithms to make your decisions in your applications. I'd really like it if people to come away with the ability to be able to critically review is this a good machine learning algorithm? Do we feel like we can trust it? But also have the ability with the right tools to be able to maybe just spin up their own little model. As simple as it may be, I think it's good that if people can just touch a problem that they face in their job, their work, or in their hobbies or interests, where they can say, oh, that's maybe how I could use machine learning. Okay, so how does this course fit into with the AI in the Wild series? Okay, so it's the first touch of machine learning. It's meant to be a really beginner-friendly course, trying to demystifying the key features and concepts behind machine learning. We're going to focus on supervised learning, unsupervised learning, and then in supervised learning, different tasks like regression or classification. Understand about workflows, so how do we go from that data to deployment? And then I'm going to take a step back a little bit and really look at the foundations of most machine learning models, which would start with linear models. And all those things, if you can do all those things and understand what they are, you'll provide the foundations to really understand some of the more complicated methods being developed and used today. So what this will require is it will require no specific maths knowledge. You'll be able to understand, hopefully at a high level, conceptually what the algorithms are doing. It will include examples of Python about how you implement these. If that doesn't, if that's not something you want to do, you can easily follow the thread without looking at these explainers. I'd encourage you to do it, but if Python's not a natural thing to you, if you're sat there thinking, oh, how do I even start with Python on my computer, then Sean's done a really lovely free course before this one called Pre-Flight Checks. It's really about how do you set up a Python environment on your computer, and then some of the basic processes, functions, ideas of setting up code, enough to be able to run all of the examples that I'm going to go through. So where do you go next after this? It's going to be into Andy's course. Andy is a machine learning expert. He focuses on deep learning in his research and his job at DigiLab. He's going to then go from my linear models into some more sophisticated methods that they use in machine learning. So this is going to include things like random forests, decision trees, vector support machines, and kernel methods. All sound fancy names, but Andy does a great job in sort of demystifying those and making them quite simple concepts that you could easily use. Just like me, we're always going to try and focus on real data sets so that you understand how you might use it in your job. I think one of the frustrating things is if they're perfectly created examples or they're synthetic examples, then often it's not clear how you could use them on real world problems. Okay, so my course is broken down into 3 sections. The first section is really around an introduction to machine learning. So there's going to be an overall explainer of, landing, why do we do machine learning? Why has it exploded recently? What are the hot topic areas? But then after that, I'm going to do sort of a deep dive and try and introduce you to 2 of the first sort of starter algorithms in machine learning: k-nearest neighbor, k-means. Don't worry about the names, but it'd be a really good idea that you can get an idea of what is an algorithm in machine learning and what might it do for you. I then want to take a step back and sort of look more abstractly about what is a machine learning workflow. Even though it's composed of different methods, actually this process from which we go from raw data to clean data to improving the representation of our data to choosing a model to training a model and deploying a model, understanding this pipeline, even if you're not going to be the person that does all the steps, is really important to know what's required to make a good machine learning model. We're then going to dive into general linear models. So linear models are more than straight lines. They're more sophisticated than that, but they are kind of the foundations of what we can do in machine learning, and they provide the important building blocks into things like deep neural networks, which you're going to learn later. Again, I'll highlight, we're going to focus examples on real world data sets. So we've got various Kaggle data sets that we'll be dropping in. You'll see some of them multiple times, but we try to show a diversity of possible data sets to sort of spike people's different interests. We'll provide Python walkthroughs. So I'm sorry for my programming, but I'll walk through you simple examples. I'll talk through the decisions I'm making. I've even included all the bits where I've gone wrong, so you can see some common errors that I make as well. You can skip the maths. So there is a bit of maths. I think it's important for those that are interested in it. But I really hope that you can walk away with this without worrying too much about the maths and focusing on the concepts. You can then go back and sort of look at the maths, understand the bits that you want to do. I think the important thing is not to do a bottom-up approach. To start machine learning by first learning all of maths is not a good way to go. You don't need to know all of maths. There are probably little bits that if you would like to delve into that would be good to know, and we'll point those out as we go along. Okay, so how are you going to learn? So primarily the unit of learning here is a video explainer like the one we're doing. Below that there will be written notes which summarize what I'm talking about or embellish more details. We'll try and give extra references and reading which are relevant to it so that you can sort of go exploring yourself as well based on the information we've got. As I've already highlighted, the sort of demos of how you do things will be coding walkthroughs, me punching in Python, getting it wrong, like working out how I've gone wrong, and then hopefully getting the right answer in the end. We will suggest examples for you to go away with, so go and try this on your own data set. Try a data set that looks like this, for example. In this platform there's also an active forum, so you can post questions. We will pop into that, try and answer as many questions as we can, and also peers might answer the questions with and for you, or you might find other previously asked questions that align with the challenges that you're having. We've also implemented well, we're an AI company, so we have to use an AI assisted learner. So on the right hand of the screen, you can type in unstructured questions and you'll get support answers using a large language model. So fun, hopefully that's useful. And you can ask questions about what this is, you know, how I do this calculation, how might I write a code for this, all the sort of questions you might want to ask, which will hopefully enrich your learning experience with us. Okay, it's just time to get stuck in now. Enough talking. We'll get straight into the explainer video about what machine learning is and why it's exploded in the most recent years. Great.